Hey guys, welcome back to the channel. I mentioned in my last video that my fuel pressure gauge was giving me bad data in the ECU in my data logs, and so I suspect that part of that's caused because it's mounted to directly to the fuel pressure regulator, which in turn is mounted directly to the engine. So I'll show you a picture. There it is right there. So fuel pressure regulator, a couple of pipe fittings, and then the sender unit itself. So what I'm going to do is remote mount this sender unit up onto the firewall and see if that doesn't clean up the signal. So that's my job for today. Let's get to it. First things first, pull the cord off of there and just set it aside. It's got plenty to reach wherever I need to. There's more. Well, I just lost the freaking gasket for it. Nice. I'm going to have to find that now or I'll totally forget that I just did that. Well, that's 10 minutes of my life I'll never get back. That thing rolled like halfway to the garage door. At any rate, at least it's not gone. So, let's see. Am I going to be able to get any size on there? I don't know. Oh, how about that? All right, so the plan of attack is to, with these fittings that I bought, and let's see, so this is a 1/8 NPT to -4 AN coupler. So that'll go into the fuel pressure regulator with the NPT end. And then these are just standard -4 AN line ends. That'll go onto there. I think you can see where I'm going with this. -4 line into there. And on the other end, it'll be -4, again, swivel end to AN. And then this is a AN to -4, I'm sorry, 1/8 inch NPT to -4 female adapter. And that'll go on here. And so by that way, it's going to be quite the stack up, but you know, there's just not much way around it. They don't make straight up -4 ends or NPT ends to a AN4 coupler, at least that I could find. So there'll be a little plumbing stacking, as there always is. It's almost impossible to find exactly the stuff you want, but that's the way I went, and it should work just fine. And so there we go. I'm going to get to putting this -4 line together and then figuring out a way to mount this on the firewall. There's no real provision for mounting it, so I may have to get creative, which I'm not very good at being creative, but we'll see. That's good. Starting the rebuild process here. All right. All right, let me get some tools to tighten that down for the final time. Now I realize I'm smashing that grommet, but that's okay. It's more important to get a leak-free seal. And I really don't care if this fitting is a little floppy, because that'll just take some more of that vibration out of it. But I think that's it. Nice. Okay, so we're essentially complete at this point. We got the wiring hooked back up, and it goes down and around and connects up to the fuel pressure regulator. It's a little tough to see, and I just put some zip ties to keep the hoses out of the way. And so the next thing will be to test for leaks and then see what kind of data we get with the new setup. I'm very curious. This could be a complete waste of time, but maybe not. We'll see.
Alright guys, so what you're looking at right here is two data logs, one taken before the modification to the sender location and one taken after the sender relocation. And you can see there's not a whole lot of difference here. So this is somewhat of an apples to apples. I've scaled each one for a 2-minute time frame from different data logs. The RPM is irrelevant. We're just looking at the graph of fuel pressure, and this is in a analog digital converter 17 on the AEM. So basically this is logging pure voltages, and then it's up to me to translate those voltages into actual pressures. We'll talk about that in a second. The problem that I was having, and I still continue to have, so that really didn't do anything, is the bottom line, but I want to talk about it a little bit before I leave the subject. So when you're talking about a 0 to 5 volt sensor, which a lot of the legacy style ones are, and even the CAN ones too, but that's a separate subject. All they do is output a voltage from 0 to 5, and then there's a conversion factor to decide what that means in real terms. So I'm going to drag a picture across over here and overlay it, and hopefully there we go. So what we're looking at here is a pressure to let me maximize that. So this is pressure along one side and voltage along the bottom axis, and this is taken right from AEM's documentation. So that's all fine and dandy. The problem is, if you look over here, the fuel pressure from 43 is about 2¼ volts and 62 is 3 volts. So most of the fuel pressures during driving are going to fall in a very narrow range of voltages from about 2¼ up to 3 and maybe a little bit more. So we're only working in this area of the graph right here. And so if you have data that looks this hairy, then it's very difficult to find out what your fuel pressure is doing at any given time. So on this gauge, this graph down here at the bottom, I can see that in this range right here, as the RPM climbs, it looks to me like the fuel pressure climbs a little bit too, and that's exactly how I would expect it to be, even though I probably didn't get into much boost there. So the fuel pressure is referenced to boost pressure, and it should be a 1-to-1. So on the gauge, I should be reading somewhere around 45 psi under normal circumstances, and then when I get on boost, the more boost I make, the more fuel pressure I should make. And so to a certain extent that is happening. I can see that on the gauge, but it's very hard to capture in real time when it's happening. So I rely on my data capture software to show me the details. So the problem is when the signal is this noisy that it's very difficult to tell what the fuel pressure is actually doing, because if we go from a moment to moment basis here, you can see over on the right hand side, I'm looking at this value over here, you can see that it's changing so rapidly that it's basically garbage. Okay, so I'm not saying that the sensor is garbage, because here's the thing: when you have an ECM, or a programmable computer for your car, gosh, I can't talk right now. It comes with a certain amount of dedicated out or inputs to determine what the engine is doing, and a lot of those are 5-volt sensors, and they read from 0 to 5 volt. So the ECM will provide a 5-volt reference, and then the sensor actually just acts as a variable resistor and changes that voltage. That 5-volt signal is regulated by the ECU or ECM to remain fairly constant throughout. It's isolated from the regular noise of the electrical system of the car. So when you buy a aftermarket sensor like this one, and so this sensor goes to a gauge in the cockpit, if you will, in the driver's compartment, and then the sensor itself has a data out cable that goes to an input on the ECU, and there's provisions for, you can add an arbitrary amount of these. I just happen to have this one picked up or hooked up to the ADC R17. An analog digital converter is nothing but just a chip in there that converts analog signals from 0 to 5 volts into a digital signal that the ECU can read. So essentially, the signal that's being provided by the gauge is extremely noisy to the ECU, but the gauge itself is reading relatively accurately on the physical gauge that's in the driver's compartment. So whenever you're doing that, a lot of times it introduces error to it. So the reason being is, if I overlay battery voltage onto this, you can see that the battery voltage actually fluctuates a little bit from moment to moment. It's not a purely even signal. And now I'm looking over here. So the battery voltage is 1393, and if I move this, you can see that it's fluctuating between 13.8, 13.9, 13.7. So that's fine for most things that are operating off electricity in your car, but because this gauge takes the 12-volt signal from the car's electrical system and then outputs a 5-volt signal to the ECU along its little line there, it's going to be subject to fluctuations in battery voltage as you're driving, and that's going to affect the output that it sends to the computer. So anything that the battery is doing here, fluctuating a volt, a tenth or 2/10 of a volt, is going to be mirrored in the signal that's output. If it's not a very good system, there should be some filtering going on to prevent this sort of thing. You see the same thing with oxygen sensors that are powered by the car's electrical system instead of being driven or powered by a reference signal from the ECU. So something to think about when you're adding gauges to older ECUs. The modern ones have enough inputs to where they can feed all these different sensors. Like fuel pressure is pretty common now to monitor, and it's built into most ECUs, but it wasn't in this particular AM. So what I'm getting at here, just a little background on noisy supply voltages can equal noisy gauge outputs, and that's what I'm experiencing. I feel like right here is that the gauge is doing its best to monitor the fuel pressure, and it's doing a fine job, but when it outputs that signal to the ECU, there's enough fluctuation in the voltages up and down moment to moment that it's just completely throwing off any usefulness of the data. It's very difficult to even determine a trend here on these things. So my suspicion that pulsations in the fuel pressure and air pockets that might have been in the line, or vibrations from the engine, were causing this erratic signal is probably not the case. Now it's possible that the fuel pressure is fluctuating on a moment-to-moment basis so badly that that's getting thrown right into the ECU just in a raw format. It's not being filtered at all, but that's not helping me any. So if that's the case, it's either look for a fuel pressure gauge that has a cleaner output and it has a more representative signal so I can make head or tails out of this, or upgrade the ECU to one that takes fuel pressure natively and can do something with it. So just a little something to think about when you're trying to decide, make decisions based on, like if I was to make a fuel trim based on this output right here, as fuel pressure goes up, fuel goes down, or something of that nature, it wouldn't work very well because I'm just not getting a good signal. So can I live with this? Yeah, I like to know what my fuel pressure is so that I can tell whether my pump is handling the demands, and the injectors are sized properly and things like that. So fuel pressure is super important on a general basis. Do I need to do anything with it on a moment-to-moment basis? Probably not, as long as everything's working fine. So you can build safeguards into your map such that you know, if you lose fuel pressure, you can increase injector duty and things like that to make up for it. But that's not something that I need to necessarily mess with right now, and I really can't because there's just too much noise in this thing. So I really felt like that would help the quality of the signal that's being reported to the ECU, and it's not. So it's very difficult to tell whether these are actual millisecond to millisecond fluctuations in fuel pressure and the gauge is reporting them faithfully, or if this is just a noisy signal due to the inherent noisiness of the car battery voltage being magnified into a fuel pressure. So you know, a tenth or two of battery voltage, a tenth or two of fuel pressure voltage based on the sensitivity of it, just a 2/10 here from 2.5 volts to 2.75 volts is a difference between 50 and 56 psi according to the gauge. And so a couple tenths doesn't sound like a lot, but when you're trying to measure down to, you know, single tenths of a volt, meaning several psi worth of fuel pressure, then that poses a problem. So I don't know that I'm going to be able to do any better than this based on with the equipment I'm working with right now. So you can't always trust everything that these sensors put out, and I really don't feel like it's a bad sensor, although it could be. I really feel like it's just the signal conditioning that is the biggest problem here. So all right, that's what I wanted to put out just to wrap this video up. It was kind of a fail, but not so much because I still learned something. And hopefully you guys learned a little bit too. We could make an entire video on the, you know, sensitivity of the sensors in your car based on the output of your alternator or your charging system. But I think that's probably goes without saying that if you have a noisy electrical system, you're going to have noisy data inputs to your car. All right, so that's enough for now. I just wanted to wrap this up and give a little feedback to what I experienced there, and let you know that was that a waste of time? No. And the last thing I'll say is, because this is the second fuel pressure gauge I've had on this car, and the first one failed completely and wasn't giving me any signal at all, and I really feel like that's because it died due to vibration being connected directly to the engine. All right, that moment-to-moment vibration on the engine is just hard on sensors. So I like to remote mount sensors when I can, just to get the vibration aspect out of it. I think the sensors will live longer, and so if nothing else, I feel like this sensor will last longer and won't die so quick because it's mounted now to the chassis and not to the engine itself. So in that sense, it wasn't a complete waste of time, but I really didn't get the sensitivity improvement that I was looking for. All right, guys, as always, I appreciate you tuning in, all 5 of you, and if you've got any questions or comments, please hit me up. I'm really trying to do my best to make interesting content, but you know, time will tell. Anyways, appreciate you guys hanging out with me. Like, subscribe, make comments, roast me if you want, and I'll see you on the next video. Thanks a lot.